Right, lovely. Anyway, thank you, everyone. So let me introduce myself. I'm Tahir Mahmood. I'm a co-founder of KRNL. Basically, that's my background. 40 years in technology. Started at Microsoft. Early years in the 80s was involved in AI, parallel execution, all of that operating system stuff. Moved on to Microsoft during my tenure without spending too much time. I've done many projects at a global level, scaled a Halo engine, over 40 published patents to my name, so I'm very much into the academic side of things and not just the pragmatic side of implementation. Okay, so let's start with traditional computing, and obviously traditional distributed computing, we all understand about horizontal scaling, vertical scaling. We understand it's centralized to be able to achieve a lot of the things that we've known in the Web 2 industry with cloud computing. So how is that different from blockchain? Well, blockchain brought about the idea of distributed computing with EVMs, and obviously what happens is you transmit a transaction into a blockchain that's executed on all the EVMs, providing you the redundancy for the network. But ultimately that comes at a price, and that price may be wasted compute. But at the same time, it's from that we're able to create the ability for consensus with all the different consensus mechanisms out there. As the gentleman before me talked about proof of work, proof of stake, DAG, all these other things. So moving forward, when it comes to sharding, and that's really what I'm going to be discussing here, most people think of sharding and know sharding from the perspective of data. So, how is it that you take the data and instead of saving it into a single database, you're able to distribute that data amongst many shards? And obviously the intention being is that if you break the data down, one, it takes less time to write it because you're not taking a way to write it to one single database. In my old days, I used to call it one, disk rotating. You can break it all up and then form it together or access it much quicker. So if you wanted to do a read, there's an algorithm, some kind of formula which says you're more likely to find the data on that shard than you are on that shard, and then basically find it very quickly. So as you can imagine, sharding is there. Execution sharding brings about this idea of, well, if we are really putting so many transactions into a network, a blockchain network, and we already know that if the blockchain network continues to grow more and more nodes, then ultimately you may have it that every single node is trying to execute every single transaction. That just seems mad, and it just seems not the right way to scale a system. In distributed computing, it's all about being able to not only run things and communicate in parallel or in a distributed way, but you've got to do it in an optimized way. Okay, so I just want to talk about a little bit about where we've come from and our roadmap. We all know Web 2. It was very simple, very client-server based. If you remember the old days, we had mainframes with terminals, so everything was done on a mainframe. Then we ended up with desktop computers, where at least you have a front end and a back end, and generally a database, which is where you hold your state. That's the very simple model. Then we move on to, on my right, what is the Web3, the blockchain. And we can all understand that's predicated on a very simple infrastructure, which is you have a virtual machine that is able to execute these smart contracts, which we know as code as law. And then ultimately the blockchain is the linked list, I call it a hashed linked list, whatever, but that's what we are. Now let me present to you something that's slightly different, and the idea behind it is how can we achieve the roadmap, just like we've had seen in Web 2, we went from mainframes to client server to cloud computing. Where is it that Web 3 is going? Surely you can't just keep continuing, I call it optimizing the bytecode of a smart contract. You can make that into as parallel as you want, but it's somewhere down the road, you've got to look at a different scheme and a different way of thinking about it. So what I'm going to present to you here is an execution sharding sort of C4 diagram from my days of being an architect. And what this basically shows you is something which says, you transmit a transaction into a blockchain node, and you can see in the center that's referred to as the kernel node. I'm the founder of KRNL. And basically in the middle is where all the technology exists, where we're used to having all the things that we expect, but we've just added and augmented it with this engine, whose job is to sort of say, you know what, is there anything I can take care of which normally, one, you cannot do within the EVM compatible smart contract itself, but number two, is there something that you can execute whose data you want to bring on board, wherever it may be. It could be on any blockchain in the whole of the Web3 ecosystem, or it could be on the Web2 in the off-chain world. So what we've done here is a rough architecture. So moving on. What we've done is, and this is again coming back to a paper that Vitalik wrote about glue, and what we've done is we've come up with this idea using pure cryptography, which is a token authority working with the node. So what we did is at Kernel, we modified the Geth node itself to include a new module. We call it an operating system, but a new module which works with a decentralized attestation service. In the Web2 world, people know it as a certificate authority, but here it's an off-chain, or it is on-chain, but on a decentralized network. Okay, now the token authority, very straightforward, stateless. It's a smart contract running on another chain. So again, very decentralized, very secure. It utilizes ERC 1271, which is private public key pairs. We modified a Geth node. The Geth node comes with a GraphQL runtime embedded. We decided to use the GraphQL runtime with its custom resolvers, also directives to manage workflow. So what we've ended up achieving is this modular approach to smart contracts, and I'm going to quickly run through this because I've got very little time. An Aave smart contract running in the EVM, broken down into its components, now run by the kernel node. You can add extra features to it, and all the advantages you gain from it basically mean you're not tied to what I called an EVM compatible world. If you want to build real world applications which give you the ability to access anything anywhere and execute it and do a state change, well, surely that's going to be better than just building EVM compatible smart contract applications. Use cases, a lot of use cases. So as I'm running out of time, I'll say thanks everybody. If there are any questions, happy to take them.
Thank you very much. Fantastic presentations. Just a quick question from my side. What do you see as being the first application that can be used with kernel?
So it's interesting. I mean, the lowest of the all hanging fruits to me are two, actually. I'm going to say are. The first is, I think we solve the Oracle problem. If anyone's familiar with that, but the Oracle problem and is to do with the, obviously we've got one of the people from Chainlink actually sitting in the audience, but we actually resolved that to the point that oracles bring about a lot of waste, a lot of processing, a lot of cost. With kernel or this technology, you're able to take that data on the way into the smart contract, all fully attested, proven, mathematically correct. Everything else you can use as, the nice words. And that way you don't have to wait for the network to do yet more. Oracles generate even more smart contracts, more emissions, more transactions. It just adds more. So that's the big one.
Fantastic, lovely. Thank you very much. Another just closing round of applause. Thank you.